Hello and welcome. Let's talk about what Docker is today. What is the important part about Docker and why is it so great? What is the big fuss about it and why do people really want to learn Docker all the time? So, Docker, what is that? Apart from this big blue whale, lots of containers on its back, which kinda is what Docker is really. So, in the end of this video, you might understand what this is all about. Let's get started. So basically the overall agenda is that we're going to talk about, what is Docker, virtualization, getting started with Docker. And the second video we're going to do a small Docker example. This is the first video, so the second video we're going to do a demonstration example of how you can use Docker in a practical manner. So I'm not going to spoil much about that, but if you're going to watch until the end of the video, you probably have a really good idea what we're going to do in the second video. Alright, so let's talk about what is Docker, right? So usually, when you have a house, you have different kind of bedrooms, and you probably have a kitchen and a bathroom, right? So the thing is, every bedroom is occupied by a person, and they need to share this kitchen and the bathroom. Now you probably think about this as a computer with different kind of programs. They need to share this kitchen and bathroom, shared memory, something like that. So the problem arises that what if they need different kind of versions and stuff? So start thinking about this thought for now. In a computer, it would be something like that. So you had like app 1, 2, and 3, and they're gonna read like libraries and frameworks, and basically that's gonna be really good. But sometimes, one app is just have some requirements that is different compared to the other apps. So then you install a second pair of libraries and frameworks that fits that app, and then you have two pairs of libraries and frameworks. Really, you only need one, but who needs to update app number 2 and 3 that need different versions, right? So now we have a variety of flavor installed in your computer, different libraries, different frameworks. Maybe that is not the biggest deal. You've probably been there. You are probably that developer already. Who knows, really? So the general idea is that it could be like, that the app 1 needs version 1, and app 2 needs version 2, and app 3 needs version 3. Then you have to install 3 different kind of versions. Now, I wrote out Ruby on Rails here, so it could be basically anything. But in reality, this is something we need to combat in some way. We need to solve this issue in some way, because this is an actual issue, it's an actual problem. We cannot have these many different kinds of versions installed, because it kind of also raises the security alert, like wah, wah. Now it's a problem, right? So what you basically need to do is just say, okay, so we're gonna delete like version 1, version 2, and then keep version 3, right? No, that is not what you need to do, because if you have a lot of different kind of things installed, that let's say version 1 and 2 is something you developed like for a long time and they're really good, then you create a new something in software and that is the only thing you keep. That's a really bad idea, because then you kind of lose all the other things. So the solution is not really just ditching stuff because it's old version. Sometimes you need to ship it over, or maybe it's really good, maybe it is already secured, really know. So, how do we fix this? How can we fix all these kind of versions and different kind of software groups and stuff like that, right? So, the way we're gonna fix this is using Docker. Now, what Docker really is now is then you have 3 different containers. Now look at this. Now we have 3 different buildings. Now, you could probably say, but hey, isn't that 3 different computers? It is not. Docker is not a computer. It is a kind of virtualization software. It is not a virtual machine. I'm gonna get back to that. It's like an image or snapshot of something running. Of course, if you need Ubuntu in a Docker virtualization snapshot image, kinda, you need the kernel, but it's kind of bare. It doesn't have anything installed. So, but in this situation, you can imagine that you have 3 different kind of apps installed that require version 1, 2, 3, and they each got a separate version running individually. Of course, they can communicate with each other. That is configurable totally easy by Docker. So that is something it can do. But that might be very expensive. Like, so is it really expensive? So many people say like, so this sounds really expensive. However, it is not. So if you take the solution one here and say like you have different kind of apps installed. So with Docker, and this is the whole thing combined together, it is on the same computer, it is running on the same computer, it is using a minimal amount of system power, it doesn't require a lot of RAM, it doesn't require a lot of, CPU. It's just like, what does really happen? It really, that is what Docker can do to you. So you can on the same computer have everything combined. No reason to think this, separate unit thing, whatever, that is the old ways. The new ways is handling Docker. This is also why everyone talks about micromanagement, on the microservices. How can you secure your microservice? How can you make sure that things are secure? That is kind of difficult because with Docker, you can basically just create loads of different machines really quickly and just spin them up and run them. So this is how it would be looking with 4 different kind of apps installed on computer using Docker. It could be needing different kind of versions, doesn't really matter. Now in reality this would require a lot of configuration if you were to run one app looking at one particular environment variable, fetching the version 1 of Ruby Rails. App number 2, fetching another environment variable. It's like already a big headache of the management, the micromanagement. All that goes away when you use Docker. It's just one container, you just run it, and then boom, you have a small virtual image running of something you need exactly. Now, the thing about these virtual images is that they don't really contain all the operating system. It's not a fully fledged operating system that runs, it's just a small snapshot of it with the service installed. Typical Docker images, I keep saying images, but it's like when you download a virtual machine and install it on a VMware, something like that, that is a fully fledged operating system. Docker is not like that. It's more like a snapshot, just needed things. Of course, that seems a bit abstract, but just think about the small pieces of software. 100 megabytes, 200 megabytes, 50 megabytes, 5 megabytes. We're talking megabytes, we're not talking gigabytes. You can find something that is gigabytes, but most of the small machines and stuff you're just going to spin up using Docker is going to be small software pieces, basically megabytes, something, right? So Docker is really just really easy to use because you can basically copy paste stuff. You can just say like, so I have these kind of rooms running. I need more room it. Then just take and create more room it, and that's running one command. You just run command, and then boom, you're gonna start out more rooms 1. That is how easy it is. So basically, I cannot recommend Docker more than this. It is the most beautiful thing in the world. So let's talk about virtualization, and just basically think about having a lot of different computers installed. It's just like it's feasible to have different computers and servers for every single application. Exactly, that'd be a big waste of resources. Exactly what it is, and it doesn't also require a lot of RAM, a lot of CPU power and stuff like that. Which is why you need to find a way to solve the problem, and you can do that with Docker. Small. Not that doesn't require a lot of resource, right? So Docker is the way to go. Looking at the normal virtual machine, you have the server here, and you have the VMware installed, and basically you have a hypervisor that's going to make sure to divide different kind of resources to the guest OS, the bins and libs, and the apps. On Docker, on the other hand, it is these small, bins and libs and app is called a one container or a container. So in this picture, we have 3 containers: 1, 2, 3, app 1, 2, 3, and there you have each their own bins and libraries and paths, and they have their own configuration and stuff. They're not communicating with each other at all. They're running up on something called the Docker engine, which is basically running as the guest operating system, you can say that, which is hypervised directly. So the Docker engine is handling everything on the app 123, and it is running really, really fast. Now the speed it takes to boot up like a small Ubuntu image with the Apache server installed, it's like 2 seconds. So it's like a snapshot of time. Boom, you have a web server running like that, and boom, you can take it down. You need to test something with some specific version of PHP. You just download the image and boom, you spin it up on Docker and boom, you take it down. It takes a few minutes and you're really fast going. Doing these kind of things on a virtual machine, installing something and configuring everything from the scratch, it can take a lot of time. So this is really just spinning up small, easy containers using Docker is the way to go again. We did talk about what Hypervisor was, so we're really not going to use a lot of time on this. You can read the text, so I'm gonna leave it for you to read. So thank you for reading it. So basically, you can say containerization is basically this is the way to go. You have the server and the operating system, and on the VMware you have the other, you have the hypervisor installed along with the along with the let me show you the image again, the guest OS for every single app, which is 3 operating systems. It's going to be a lot of stuff to install. So talking about what is a container. Now, as we talked about, containers can run different kind of things. One of them could be like a Tomcat Java Debian system, and one could be PHP, MySQL, Ubuntu, and it could be static binaries with Alpine, some Linux stuff running, just on computer. It's a small, lightweight, snapshot, standalone, executable package, piece of software that includes everything you need to run it, like code, runtime, system tool, libraries, binary settings, and everything. So basically, a small container on Docker is going to be the most easy thing just to spin up. If you want to run, let's say, something like PHP or some Java-based web application archive file, you can basically spin any container up in a few minutes and just boom, you're going. You take it down and spin it up again within a few seconds, really. You can do all that on a VMware installed. It's going to take hours of configuration and testing before it really runs. So getting started with Docker is kind of easy. You don't really need a lot of knowledge of Linux or commands or stuff like that. They created Docker with an easy to use interface. If you're going to use Windows, you need to install something called Docker Desktop. Now I wanna give you like a small tip here. When you install Docker on your computer, there are some requirements for you having virtualization enabled in the BIOS. So you have to go in the BIOS and enable that through like either pressing delete button or F2 or F10, whatever is visible on your screen when you boot your system. Also, might need to do some certain kind of configuration on your Windows machine, depending on which kind of operating system you're running. It could be the Mac OS X, or it could be Ubuntu, and any Linux distribution. But in my sake, I used Windows 11. And you did need to go in. I did need to go in and enable virtualization a few times through PowerShell and some few other things you need to do. So depending on that, you might need to do some, different kind of configuration stuff and Google your answers a few times. So that's just, a few tips for you when you install Docker, because you need this virtualization enabled through the BIOS before you can run it, and it will kind of yell at you if you don't do it. So basically, just go ahead and do that. One thing I want to talk about is Docker images versus containers. When you build an image from Docker, you can do that pretty easy. It's called something called a Docker file. Then you say like, okay, so I need the snapshot of Ubuntu. I need to install a few binaries on it. I need to install, let's say, Apache and a PHP server. And then you can run application just, as well as fast as you can do that on a normal server. So that image is immutable. Basically means that you cannot change it or anything. It is non-changeable, but you can actually run it, and when you run an image, it becomes a container. So that's really just the analogy you're going to use when you use Docker, is that images become the container, and you can create changes to the container. Just remember to stop it before, and then you can commit some changes and kind of just make a copy of that. So if you want different kind of versions with different kind of things installed on the image, that becomes the container. I know it's complicated, but you will get it at the end. We can just create, more versions of it and commit it directly. And if you wish to do that, you can upload it on a shared cloud drive and share it with anyone else, and you can use your machine. Different kind of URLs you need to know is a free online alternative, more or less for Windows, called labsplaywithdocker.com. I'm going to put the links in the description below, so check it out there. If you are want to install Docker, you can go ahead to docker.com/install. You can also just go to Google and do Docker install, type that in Presenter, and you're going to find the same link there. So, in the next video, we're going to create a small thing. I think I'm going to create a container using Apache PHP and a small container using MySQL, so they're gonna communicate with each other. Just a very basic web application, nothing crazy, nothing with graphics, just the overall idea how we're gonna create that really fast. So that's gonna be in the second video. It's gonna be a demonstration for me. Gonna use it on Windows 11, so we're gonna follow along. Please make sure that you install Docker Desktop and you're ready to do some commands in the command line. Really hope you got something from this video and you understand now what Docker is and you can use it for. If any questions, leave them in the comment below. I'm going to get back to you as fast as possible. See you out there.